So the difference between a geometric sequence and an arithmetic sequence. We had been looking at arithmetic sequences the last couple weeks, and we realized that that is a sequence where you can add or subtract some sort of common difference from whatever term you're on to get your next term. And that common difference stays the same, much like a linear equation. What we're going to look at now are geometric sequences. And geometric sequences increase or decrease by some sort of ratio. And when we think ratio, we should be thinking multiplying some sort of number, whether that is a positive number or a negative number, a whole number or a fraction. We should be multiplying something by some sort of number in succession, so one after the other, and that will be our common ratio. So now instead of having a common difference, we're going to have a common ratio, and we're going to pretty easily call that R. If you look at the example that we have here, we've got the number of bounces of a bungee jumper the height of a bungee jumper after a certain number of bounces. And we can see this would continue on 4, 5, 6 all the way through. Now the heights are a geometric sequence. It goes from 200 to 80, and then from 80 to 32. Now if you look at this, obviously it's not arithmetic because we're not decreasing by the same amount each time. This one here we're subtracting 120. This one we're subtracting 48. So we can see it's not arithmetic since those two are not the same. So then we have to check to see if it's geometric, which it is, but the easiest way to find the ratio is to take whatever your next term is and divide it by your last term. So our ratio should be 80 over 200, which really will simplify down to 4/10. Now, to double check this, we got to do the same thing between 32 and 80 to make sure that these two will reduce down to be that same ratio. And as long as they are that same ratio, then that is going to be our common ratio. 32 and 80, if I divide them both by 4, I get 4/10. We can see here those two ratios are the same. So I've got 4/10 and I have 4/10. So I could say that this is a geometric sequence with a common ratio of 4/10 between my bounces. So for every bounce that occurs, the height decreases by 4/10. It starts as 200. After one bounce, it goes down to 80. After another bounce, it goes down to 32. After another bounce, you would be able to multiply it by 4/10 again, and that would give you your fourth bounce height. So we can see it's kind of similar to an arithmetic sequence. The only difference now is we're multiplying or dividing by a number. And if we look here, this is probably an even better example where we can see it. If we have a sequence, 1, 4, 16, 64, and we're looking for the next three terms, well, we've got to see what the common difference is. And from 1 to 4, we're adding 3. From 4 to 16, we're adding 12. So we can see right here, this is not an arithmetic sequence, since we're not increasing by some sort of common difference each time. But what you probably already noticed is if I take 1 multiplied by 4, I get 4. If I take 4 multiplied by 4, I get 16. 16 multiplied by 4, I get 64. So you can see here that our common ratio, or our R number, is a 4. Anytime that that number is larger than 1, it's going to increase. Anytime it's between 0 and 1, it's going to decrease. And the same thing for the negatives. If it's a negative number, it's going to just flip back and forth in signs between positive and negative. Now, the question saying find the next three terms in the geometric sequence. So, like we just said, we took 1, multiplied it by 4. Took 4, multiplied it by 4. 16, multiplied it by 4. So now we're going to take 64, multiplied by 4. We would get 16. Oops. We want to take 64 and multiply it by 4. And we get 256. Got to do the same thing with 256. Multiply by our common ratio, which is 4, and that'll give us 1024. Do the same thing to find our third and final term. Take this number, multiply it by 4, and we get 4096. And now we can talk about this just like we talked about our arithmetic. This is my initial term. This is my second term, third term, fourth term, fifth term, sixth term, seventh term. So we can talk about it as being terms in a sequence. But that's as simple as it is. If we find the common ratio, then it's pretty easy to find the next couple terms in line. Now, another good representation of this, just so you understand the difference between the position and the term. So this is a new example that starts at 3 and it multiplies by 2 each time. So for this one, our common ratio, which is our R term, would be A2, and we can see that they're increasing by 2 each time. Now, what this is showing us here is that our first position is our first term, which is the initial term, and the value of that term is 3. So the value at position 1, that term is a 3. Same thing here. The second position, that term is a 6. The third position, that term is a 12. Fourth position, that term is a 24. So these, again, just like we saw with arithmetic, the A1, A2, A3, A4, those are all kind of just keeping track of where we're at in the sequence. A1 is the first term, A2 the second term, A3 the third term. Very similar for plugging in an x into a function. If you did function of 1, that would be the function when evaluated at 1. This is just A1. And then our arbitrary AN, if we're writing our equation, we're going to use A of n because we're not sure which exact step we're on. But if we know the step, say it was the 8th step or the 9th step, we could plug 9 in for n and we can solve it. And the only way that we can solve it is by having some sort of equation. And this equation looks very similar, at least it has a lot of the same parts as our arithmetic equation. So if you could see up here, there's really 3 different good columns up here. Words, which is the first term, the second term, the third term, the fourth term, and the nth term. And numbers, which is the same one we were just going over. Our initial term was a 3. Our second term was 3 times 2, which gave us a 6. Third term, 3 times 2 squared, which is a 4, which gave us a 12. Okay? So we can see it's doubling each time. So we've got our common ratio, which we said our R value is a 2. Right? We know our initial value, which that A1 value was a 3. Now if we look down here at the formula that we're going to be using, really those are the only 2 things that we need to know to set up our formula. Because we can see here we need to know what was the initial value, what's the common ratio, and then the rest of the stuff that we're plugging in is just which step are we on. Now the one, well, I guess it is similar to the arithmetic because we're not just plugging n straight in, we're plugging in n minus 1. So if we're talking about the, let me get rid of some of this writing up here. If we are talking about the fourth term, which would be here, we're actually plugging in n. Our value is a 3. So we're taking whatever term we're on, subtracting 1. Okay, but really the only thing you need to know is find what the common ratio is, find what the initial value is, and then you can plug everything into this equation, put it all together, and you've got a geometric function or a geometric sequence. And if we look at it, we've got our equation down there. Pretty good example here. This one lays everything out for you. It's telling you that the first term of the sequence is 500. So I would say that my A1 value is equal to 500. The common ratio is 0.2. So I can say my R value is equal to 0.2. And it wants to know what is the 7th term of the sequence. Well, we could set it up and say, well, our initial value is 500. And then it decreases now, since this is a 0.2. So I could do 500 times 0.2. And I would get 100 as my second term. And I can do it again. 100 times 0.2. And I get 20 for my third term. I could do it again. 20 times 0.2, get 4. Times 0.2, get 0.8. 1.16, and if we did it one last time, we would get 0.032. Now, we can do it like that. We can write it out that way, but it's much simpler to just use our function. So if I look at this, according to my function here, a of n, well, n is the 7th term, so I would say a of 7 is equal to a of 1, which is 500, times my ratio, which is 0.2, raised up to the n minus 1 power. So it would be the 7 minus 1 power. So if I simplify this down, it would be 500 times 0.2 to the 6th power. And if we do a real quick calculation, 0.2, we want to raise it up to the 6th power. We get 0.000064. Multiply that by 500. Ends up giving us the same exact answer with a lot less work. So we can use that sequence that we came up with. And if I write the generic one, it would be n equals 500 times 0.2 raised up to the n minus 1 power. Now, the only other thing you have to be careful of is if you have a negative ratio, you have to make sure that you put your parentheses and your negative inside of the parentheses. But besides that, really everything works just like we've been working with it. If you know the initial value, you know what step you're on, and you know what the ratio is, you can really come up with any value of whatever term you want.